EdgeStar Technical Support. Here with me we have the DWP61ES Portable Countertop Dishwasher. This is a technician level component replacement video. Customers can view this as well. However, we strongly recommend that you get a professional to do this for you. This does cover both the 60 and the 61 series of dishwashers. In this segment I'm going to talk about water pressure. Water pressure for this dishwasher is very important for proper operation, clean dishes, and of course a happy customer. So what we want to talk about are some of the causes of low water pressure, error codes, why the unit won't wash, and any other troubleshooting that we run across while you're servicing this unit. First thing we're going to talk about is the water pressure specification. It is 15 to 20 pounds per square inch. Now the customer has no way of measuring this, and more than likely what's going to need to happen if we discover in the end that the customer has low water pressure on their end of the installation, then they're going to have to get a qualified plumber out there to check that. First thing we want to check is the installation of our kit, which comes with a unit for hookup. This is our dishwasher adapter. By hitting our bypass button, this gives us a pretty good picture of how much water pressure we have. If it's just dribbling out, we have a problem on the customer's side. If it sprays out really hard, we know the pressure's okay and we have a problem somewhere else in the line. So this is included as part of the kit. One of the first things that we look for is just simple troubleshooting. Let's start with the simple stuff. And the first thing we look at is a kinked hose. Is the supply hose kinked, or is it straight? Is it pinched with something? This can be a major cause of malfunctions and error codes. The next thing that we want to look at is on the inside of our unit here. And as you can see, I've taken this apart so that you can see it easier. This is our electronic inlet valve. It has two wires, a solenoid assembly, the filter, and the inlet assembly itself. And then on the other side we have the outlet, which goes over to our flow meter. I'll show you that in a minute. A lot of times we'll find that the unit fills up really slow, and we end up having an E1 error code on the display at the front of the unit. Now there could be a lot of reasons for that, the biggest one being that water pressure, but we also find a lot of customers don't have any filtration on their system, or they're on water with a high lime content, well water and such. What that does is it plugs up this really fine screen back here. The water barely trickles in, and then we get that error code. So we need to make sure that this filter is always kept clean. Probably after 6 months or so, we're going to have to go in there and clean that, and of course that depends on how hard the water is at the customer's home. The next part I'm going to talk about here is our actual flow meter. Now I've disconnected the wiring to it. As you can see, there's a plug there. However, this part is what actually does all the measuring on the unit, and it will tell us and will give us an error code if the water pressure is not right. So those are some basic parts, how they work and how they relate to water pressure problems. We also want to make sure that when we troubleshoot this, that on the customer's end of it, we need to make sure that their water valves underneath the sink are actually fully open, that the tap or the quick connector that I showed you earlier is connected. We want to make sure that that is fully open as well. Those can cause issues with water pressure. Another issue that we run into sometimes is that the customer will complain that the unit is not heating the water. This does contain a small booster heater. It's right here in the center plenum assembly. Actually, you can see here at the end, and I'll move this out of the way for you, you can actually see the thermostat and the element where it actually comes out of the end of the casing. A lot of times we'll find that there's a problem electrically here. So what you would want to do is we need to check some things first. Before I do that, I'm going to show you the actual element here. And here it is sticking out of the end of the casing. This is all enclosed, obviously. Here's the ends of our connections. It's similar to an oven element. It's a 600 watt unit. This part usually ohms out at about 10,000 k ohms. If it's open or infinity or any less than that, you can pretty well be sure that it's probably bad. So what we want to look at here is how we take this part out. I want to cover that while I'm in here. So you're going to disconnect your wires here at the thermostat. You always want to do a resistance test on your thermostat. Obviously you should be able to do that. And you're also going to do a resistance test between this terminal and this terminal here on the ends of that element that I just showed you. To remove this element from its casing, what we're going to do is you'll find two screws at the bottom, just like these two here at the top. We're going to pull all four of those, slide the element out of its casing, and then we're going to put the element back here in this lid, and then we'll go ahead and close it back up. And of course you're going to want to mark all your wires, make sure that you don't mix them up and you get those put back in the proper order. That will usually solve any heating issues that we're experiencing with the unit. Another area where we find some trouble at is our main wash pump assembly. A lot of times as a technician, you'll find that the customer will come to you and they will say, look, my dishes are dirty, my spray arm's not spraying, it's not turning, it's just not doing the job. So there's several things you as a technician can look at and see for yourself and do a little bit of troubleshooting. So I'm going to show you how to do that. The first thing that we want to do is we want to talk about our spray arm. And our spray arm has a series of holes in it, as you can see here. We need to make sure that all of those are clean, that you can clean them out with a toothpick. That should suffice. When you're done cleaning those out, you can actually flip this around, run some water into the center hole, and they should come dribbling out of each of these holes. That's the first thing we need to check, especially with a customer with high mineral content. A lot of times this stuff will plug up. If that fails and that part is clean and we know that everything else is in line, then we can start looking at the main motor and the relay assembly. And so here it is in all its glory. And basically this motor here, it's easily removed. I'm going to talk a little bit about testing and then I'll show you how it comes out. You need to check your continuity on this motor. Check each winding. Make sure we don't have any opens or shorts. It's not grounding somewhere it shouldn't. And we also, behind this motor, we have the main wash relay. This relay here is connected. You need to check it. There's specs here on the label. It should fall within specification. If it falls outside the specification or it doesn't work at all, then obviously we need to replace that. In the event that you have to replace this wash motor, there's just a couple of simple steps here. You're going to label, tag, and disconnect your wiring, of course. That's going to be the first thing on your list. And if you look, we have 3 screws on this unit. There's one opposite of this one on the other side, and this one up here at the top. And you're also probably wondering how to get this out. Well, the easiest way to get this out, there is a rubber mount back here. We're simply going to pick up the front end, slide it forward, pull the motor out, and it's free. And you'll do the same to put it back in. So we're going to give it some clearance, push it forward, push it backwards into the mount, and then you've installed it. So what I want to talk about, just to give you a better view on the bolts and everything here, I've got a motor that has been pulled out. And as you can see, here's the back end of this. This sits in that rubber mount. You've also got your associated wiring here. And then around the front of the pump, we have the impeller. This should turn. You need to check it and make sure it's not binding. If it is binding, it's stuck, this motor's really not serviceable beyond that, so you need to replace it. That's really the solution for that. That pretty much covers the main wash pump assembly and how it bolts on. And that's pretty much it for the troubleshooting on that particular part. Alright, on this segment we're going to be covering the drain pump assembly on this unit. There is one pump that does all the work for that. A lot of times from the customer we'll hear them say, well, it takes forever to drain, it doesn't drain at all, I'm getting an E3 error code for a long drain time. So all of those things, we can pretty well be suspect of the drain pump motor and its associated wiring and circuit. So what I'm going to show you here is the drain pump, how it's connected to the main sump assembly, where the wires are, and what we should be doing to troubleshoot this. So to begin with, I'm going to show you where it's located. This is the front end of the sump here. I'm going to pick it up and turn it. I've already disconnected a lot of things from it so that I could do that. But as you can see, it has 2 prongs here. There's 2 sets of wires. They both should be hot. This one here actually self-grounding. This motor is not really serviceable. It's like the main pump. There are a couple of things that you can look for mechanically, but I'm going to cover the wiring for now. So you've got your wiring coming in here, 120 volts. There is a bolt at the bottom of this pump and the top for removal. You need to remove it. You can actually remove it from the sump assembly, run it and check it that way and make sure it's turning. This is a magnetic type motor. This does not have a winding. As you can see, it's a solid core here. So this is magnetic induction. Kind of like an aquarium pump, if you will. Same principle. So to remove this, you would pull this bolt here and this screw up here, and the whole thing slides out. Now I've got one here that I've taken off, and I want to show you the inside of it. I'm going to bring it up to the camera here a little bit. This is your impeller inside the unit. There's also an O-ring gasket here at the side. This seals this to the main pump, the sump body on it. And then of course, here on the ends we can see our bolt holes. You've got one here and then one down here. So if this motor is functional, you pull it out and this spins, then it's probably in the circuit somewhere. If this is stuck and won't turn, then you can suspect that. This really isn't removable. If this is stuck or jammed in any way, we need to replace this entire piece because, again, it's really not serviceable. So, and that covers the drain pump. One side note, these wires are 120 volts, so if you check them with a voltmeter, that's what you should be getting during the drain cycle. And then that's pretty much covers the drain pump assembly. The other thing you can check here also is the actual drain lines. On the side of this sump assembly, that's a little tough to see, but there are hoses here, and this hose runs right off the sump up into this air gap here. So what you need to make sure is that these hoses are clear of any obstructions, including the air gap. If there's anything stuck in here, it's not going to drain, or it's going to back up, and we could potentially burn out the pump motor. So not only do you need to check the pump motor, you also need to check all of the drain lines as well and make sure that they're clear. I hope that this DIY video has helped you maintain and service your dishwasher. If you have any other questions or concerns, please contact us at www.edgestar.com.